Okay, Algebra 2 students for Fry. Once again, I'm looking at the solving or systems of linear inequalities. And I was interrupted by a Zoom call. So picking it up at number 7, you have here in pencil, I solved y is less than negative 2/3 x plus 1. I started at plus 1 here. My negative 2/3 is I go down 2 over 3, down 2 over 3. I make my line. It's a dotted line because it is only less than. Okay, and then I shade everything below the y values. So it's everything below this line, this dotted line. That satisfies this inequality. Then I do this inequality. I start at negative 2, and this slope is up 1 over 3. So up 1 over 3, up 1 over, don't mind these two dots. I counted wrong at first. So, and that's a solid line. And then where are these two shaded areas, the red and the pencil, where they are combined, that is going to be the solution set for these two inequalities. Going on to number 9, I graphed the first equation in pencil, inequality in pencil. Negative 2 is right here, and then my slope is down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. I just kept it going and made a dotted line because it can't be equal to. My red one is in dotted line 2 because it cannot be equal to. It's only less than. And I started at positive 2, and I go up 1 over 3 for my slope, up 1 over 3. Up 1 over 3. I shade both of these where the two shaded areas collide. That is the solution set for both of these inequalities. For number 11, now I have to change this. I have to change this from this equation to this equation. I just get y by itself on one side, so I subtracted an x from both sides. Same thing here, I subtracted a 4x. You could see I made a mistake. I shouldn't have shaded this little area here. My shading went a little bit awry, so I should have stopped it right there, and then the shading of the yellow where where the solution set is for both of these inequalities. Okay. Pause this as needed, as I know I'm kind of rushing through. In pencil, you see the equation for the first inequality. And then in red, you see the second inequality and how I had to change that, how I changed that inequality to get y by itself on one side. And then you see where they collide is just this little tiny triangle down here. Number 15, I had to go through 2 steps for both of these, and here these steps are in order to get y by itself on one side. In pencil is the first inequality, solid line, because it can be equal to. In red, it's a dotted line because it cannot be equal to. It can only be greater than. Look at what happens here. It then becomes less than because I am dividing by a negative. Remember, in an inequality, if you're dividing by or multiplying by a negative, you have to flip the sign. So you flip the sign, and it comes out to be this. The only solution set, the only part of this graph that's the solution set is this tiny little triangle here. Okay. For number 17, it says which x values make the ordered pair x, we're not sure what the x would be, and negative 5 being the y value, a solution of the system of inequalities presented by the graph below. So we want to find my negative 5 on the y value, so that's right here. So between here and here, what x values are going to be working? So here I see a 3 to make this work. I see a 3, 4, 5, 6, 7. It can't equal 7 though. Okay, it's got to be less than 7, so that's why this is the best answer. It could equal 3, okay? It's going to be more than 3, but it's going to be less than 7. So we're talking about this section right here because my y value is negative 5. Try 18 if you understand 17. Hopefully I explained it well. So number 19, in a community service program, students earn points for 2 tasks, painting over graffiti and picking up trash. The following constraints are imposed on the program. 1, a student may not serve more than 10 total hours per week, and a student must serve at least 1 hour per week at each task. So let G equal the number of hours a student spends in a week painting over graffiti. Let T equal the number of hours a student spends a week picking up trash. And write a system that represents the imposed constraints. Now, I was thinking, how am I going to make it look like this? These problems that we've been doing, it doesn't really work out that way. It ends up looking like this. Okay, so the graffiti and the trash pickup, both of them together, they could equal 10 or they have to be less than 10. Can't be more than 10 total hours, okay? For each of them, for the graffiti and the trash pickup, you have to have at least 1. It could equal 1 and more than, okay? And the T is going to be greater than 1, more than 1, or at least 1, okay? So it's going to look like that. All right, hopefully this helps, and try those even ones.